everybody should be on page 14 for combining like terms. Okay, we have to learn about the parts of an expression, okay? We have to be able to combine like terms in an expression, okay? Like terms seems like a word that doesn't make much sense, right? When you say like terms, it's almost like you're saying something that's in a foreign language, but you're not, okay? Like terms is a term for algebra, okay? What do you think like terms are? Like means what?
Like you like it.
Like, are we like?
Yeah.
We're both people, right? Yes, okay? Now, are my dog Max and I like? No, because he's a what?
A dog.
He's a dog, and I'm a human, okay? Scissors and rulers, are they like?
No.
No. Justin's looking at me like I'm crazy because this is what? Scissors. This is
A ruler.
rulers, okay? They're different, okay? And that's what we're going to be doing today. We're going to be deciding what's alike and what's different. So today, our focus statement says, I can identify the parts of an algebraic expression as well as combine like terms. And this is printed on your paper. If you were at home, would you have to print this paper? No. Could you write this in your journal? Yes, you could. Okay? All right, we're going to talk about a few things just as a review, okay? Last week we talked about what the word variable means. What does the word variable mean? What is a variable? It's like the temperature during the day. Does it stay the same or does it what? It changes. So a variable, is that going to be something that stays the same in our expression? It can change. So, it can change. What do we use for a variable in an algebraic expression? Might want to look back.
It does not change. That can change.
It can change, but we use a what?
Letter.
We use a letter to represent a variable, okay? You don't have to write this part. This is already on page 11 in your journal. If you look back on page 11, both of these words are there. Constant is like your heartbeat. Constant means what?
It's the same.
It's doing it all the time. So it's something that what? Does not change. It's usually a number. No letter, no variable. Okay? So let's look at this expression I've got right here. Okay? So, my expression right here, do I have a variable? What is my variable? The y. The y is my variable. Do I have a constant? It's a number by itself. There's no letter with it.
Seven.
7, okay? And it is what kind of 7? A plus 7. It's a plus 7. You've got to keep the operation sign. Now, what did we not label here? We didn't label the 3, okay? We didn't say what that was. So, let's talk about, we just did that part. Let's see.
You go ahead and take this then.
Yes, you can go ahead and take that in. I'll give you 1 second. All right, the first thing we're going to talk about is what a term is, okay? Now, if I am a president, my term is how long? 4 years, okay? So it's a set amount, right? If I'm a governor, how long is my term? 4 years, okay? Every term is 4 years, okay? So a term has a beginning and an end, all right? A term in our expression here is each number or variable that's separated by an operation sign. So I have term 1 here, and I'm going to put a T1 for term 1, okay? I'm going to put, you have to keep the operation symbol. A T2 for term what? 2. The next one, what do you think I'm going to put? Term 3. And then the last one, I'm going to put what? So, how many terms are in this big expression that I gave you? 4. Okay? There are 4 terms in this expression. Okay? I want you to write that definition for the word term. Term is at the top of your paper. Okay? It is the math number or variable separated by operations. All right, coefficient, okay? What does the prefix co mean? Sometimes Miss Andrews comes in my math class on Wednesdays, and she teaches with me, okay? Like, she helps a group while I help a group. So, we would be called co-teachers.
She comes in and she helps you with it.
She helps me with it. So do we do it together? So what do you think the prefix co means?
It's like helper.
It's a helper. It's together, okay? Co means that you are together. If you cooperate, you what?
Helper.
Work together, okay? If you have parents that co-parent, they what? Parent together, right? Okay, so co means together, all right? A coefficient is a number that is together with a variable, okay? A coefficient is a number that is together with a variable. It tells you how many of that variable, okay? So the number, I'm gonna write that at the bottom right there. The number and the number is together with the variable. It is together. The number is together, just like The co-prefix means together. All right, so how many x squares do I have? What's my coefficient for x squared? How many x squares do I have?
1.
What's my number in front of my x squared?
3.
3. So how many do I have?
3.
3. That is, oh, goodness gracious, Dave.
Oh, wow.
That was way big. This is a coefficient, okay? 3 is a coefficient. How many x's do I have right here?
3.
Right here. What's my number here? Do I have one? Nope. But how many? Can you tell me how many x's that is?
1.
1. Just 1. So I am going to put a 1 right there. Because if there's not one there, it's a 1. Okay? My 2 is a constant, so I'm not going to worry about that. There's no variable, so there's no coefficient there. How many x's do I have here?
1.
4. So what my 4 is my coefficient here. Okay? All right, what I would like for you to do, we're going to skip that for just a second. Don't fill out that sentence right now, okay? I'm going to come back to that part. I want you to write this first one up here at the top, okay? This one. 4 plus 3x plus 2y. And we're going to figure out how many terms are there, okay? How many terms are in that expression? All right, a term is the number of the variable that's separated by the operation symbol. So how many do we have here? We start with the first one. So that's what?
4 plus
1. Then I have what?
30 times
3 plus 3x, that's the second one. And plus 2y. So how many terms do I have?
3.
3. All right, I want you to work on this one by yourself. And I'm going to walk around and see what you get. 8xy minus 4. How many terms are there? Remember, terms are separated by operation symbols. Terms are separated by operation symbols. How many do we have, Ava?
2.
2. 1 is here. 2 is there. So we have 2 terms in that expression, okay? All right, I want to try something else. I want you to write this example right here. This one that says 16y plus 2x. And I want you to, we're going to identify the coefficients. Coefficients are the what? Numbers in front of the variable, okay? So I want you to write this expression down, and then I want you to write, or you can put an arrow showing what the coefficients are. All right. Do I have a coefficient with the y? What is it? 16. So 16 is a coefficient. Do I have a coefficient with the x? What's together with the x? A 2. So my coefficients are 16 and 2. I want you 8ac plus 6ac. I want you to identify the coefficients there by yourself. All right, so what are they? All right, Caitlin, what are they? 8 and 6. Yes, I know, that's what you had on your paper. 8 is here and 6 is here. So my coefficients are 8 and 6. Yay! Okay, now, like terms, okay? Like terms is like one word in math, okay? We say it together all the time, all right? Like terms must have the same variable and the same exponent, okay? If it does not have the same variable and the same exponent, it is not alike, okay? Does that make sense? So, it must have the same what? Exponent and variable. Josh, it must have the same what? Exponent and variable. TJ, what must it have? Justin, the same variable and exponent. Caitlin, it must have what? Bree, it's got to have the same. You cannot put a Y with an X, okay? Because you have to think about it like this. Remember, Justin and I were talking up here at the beginning of class. Think about scissors as your X, rulers as your Y. Can you put them together? No. Okay? Now, if I have an X squared, that might be like, okay, well, I have some gray scissors and I have some red scissors. Okay? Can I put my gray scissors with my red scissors? Nope, because they're what? Different colors. Okay? They're both scissors, but they're what? Different colors. Okay? So you've got to keep the variable and the exponent the same, okay, if you're going to put them together. So, let's practice. I've got some steps up here on my poster, and we are going to use these steps every time, okay, just like we did with the tables. So, I want you to copy this one in your journal. 4x plus, let me change that. 4 plus 3x plus 2x. This is the one that I want you to write right here in your journal. Oh. I want you to write 4 plus 3x plus 2x. Then we're going to follow these steps right here, okay? All right, what does step 1 tell us to do?
Put a T at the front of the exponent.
All right, put a T, a plus sign, at the front of the expression, okay? Is there a symbol at the front?
No.
No, we've got to put one. So I'm going to put a plus sign right there in front of the 4, okay? Because just a plain old 4 is a positive 4, okay? What does step 2 tell us to do?
Put a 1 in front of any single variable.
Put a 1 in front of any single variable. Do I have any single variables? Any variables that are by themselves?
4? No.
Does the 4 have a variable?
No.
The 4 does not have a variable. So we're not adding a 1 to that one. There's not one. Sorry, my throat was dry. Okay. Step 3 says what?
Use a color pencil to circle terms with the same variable in exponent. Keep the operation sign.
Okay. I want you to get colored pencils out. Okay. If you need colored pencils, raise your hand. Who needs colored pencils? I want everybody to pick a blue. I don't care what color, what shade of blue. You just need a blue. Any blue will do. If you need a blue, raise your hand. All right. I want you to circle this +4 with a blue. Do not color it in. I want you to circle it, okay? Circle it with the blue. All right. Do we have any other constants? Any other numbers that are by themselves? No. That's our only blue, okay? Now, I want you to pick a red. I can't pick a red, but it's kind of a pinkish color, so I'm going to use this because I want them to be completely different colors, okay? And we're going to circle +3x. Do I have any more x's that don't have an exponent? (2x). Does x have an exponent there? So are those the same? Yes, those are the same. They have a different number in the front, but the exponent for the x's is the same. So those are the same color. Those are like terms, okay? So what we're going to do, I'm going to put these together, okay? Because those go together, okay? Your constant always goes at the end. So we're going to move this to the end in just a minute, okay? But we're going to do this first. We have plus 3x plus 2x. So how many x's do I have? If I have plus 3 plus 2, how many do I have? 5. Plus 3 plus 2, I'm putting those together, and I have how many? 5. So I have 5 x's, okay? Now, when you get to a point where you have multiple terms, it is my suggestion, once you rewrite it, you mark them out. Because you've used them, they're done, okay? Now, we're left with plus 4. Nothing else goes with that plus 4, so we're going to leave it right there. And I'm going to mark it out because I'm done with that, okay? Now, can I put anything else together here?
Nope.
Nope. So I'm done, okay? All right, I want you to write this one down here. 2b plus 8c plus 3b minus 4c. I want you to write that one, and we're going to put the stuff together for that one. All right, I want you to pick yellow. Step 1 tells me to do what?
Put a T at the front of the expression.
Put a plus sign at the front of the expression. Step 2 tells us to do what?
Put 1 in front of any single variable.
Put a 1 in front of any single variable. Do I have any single variable? No, I do not, so I don't have to do that. Step 3 tells us to do what?
Use a colored pencil to circle the terms with the same variable and keep the expression sign.
So I want you to take a yellow, and I want you to circle plus 2b with yellow. Do I have any other b's that don't have an exponent?
Yes.
Where? 3b. And I've got to keep my plus sign, okay? I've got to keep my plus 3b, all right? So it tells me what to do with it. Now I want you to pick a green. My next one is plus 8c. I want you to circle that one green. Do I have any more C's?
No.
Yes.
Where?
4C.
What kind of 4C?
9.
Minus 4C. Okay, this is where it gets a little tricky. Okay, I want you to look at me because I want you to pay attention. When we have a lot of terms and they're spread, our like terms are not together. Here, our like terms were together. Do you remember that? Here, are they together? No. I like to rewrite it so that they are together, okay? So I'm going to rewrite this right here. So I've got my plus 8c because I'm going to keep my symbol, and I'm going to mark it out because I used it, okay? So I know I've already done that one. And my other green one is a minus 4c. And I'm going to mark that one out because I've already used it. I am still going to circle these green because I need to know that those what? Stay together, okay? Now what do I need to write? My yellow ones. I've got plus 2b, and I'm going to mark it out because I've used it, and plus 3b, and I'm going to mark it out because I've used it. What color should I circle those?
Yellow.
Yellow. To know that those are together. Okay? Am I finished? No, because I've got to put the ones together that can go together. So, let's see. 8C minus 4C is how many C's? 4. 4C. Plus 2B plus 3B is how many B's? 5. Plus 5B. Now, I want you to read right here what it says. Put variables in alphabetical order. Are my variables in alphabetical order? Nope. So what do I need to do?
Switch the 5B with the 4C.
Yep. I can switch them because what operation is here? Plus. What property is that tells us we can switch these?
Commutative.
The commutative property. Yes. So I can write 5B plus 4C. And that is my what? That's my answer. Okay?
Why don't we add up the final product?
Because I can't add the B's and the C's together. That's a very good question. Because you want to say there are 9 BCs, right? We can't do that. Because tomorrow and next week we will talk about, and I may hold off tomorrow. I'm going to think about that. Because you may need to practice this some more tomorrow, okay? Because if I tell you that B equals 2 and C equals 3, okay? If they equal something different, can I put them together? No. Okay? That's tricky, all right? And that's a great question, Ava, all right? Now, what we're going to do, we are going to practice this a lot, okay? But I want you to click here for your exit ticket for today. Or not. Y'all know how much my board loves me. Okay. All right. It's going to ask for your name, not your email. I want you to look at me for just a second. The first question asks you how many terms. The second question asks you to identify the coefficients. I want you to list them in order, okay? And it's supposed to be 6A plus 9B plus 3C minus D, okay? I don't know why it did that. I'll have to try to fix it. The third one and the fourth one ask you to combine like terms. You may want to use a piece of paper. If you want to use this paper that you're writing your assignments on, if you want to turn it on to the back, because you only got one more day this week. You can turn it on to the back and work those 2 bottom ones out on the back of your paper, okay? But I want you to do that, and I want you to click submit.